All right, let's talk about something that's totally crucial to our digital lives, but, most of us never even see it. It's the test strategy. This is the secret sauce, the blueprint that makes sure the software we use actually, well, works.
You know that feeling, right? You download a new app, you're excited to use it, and then it just crashes. Or you're on a website. You click a button, and absolutely nothing happens. It's so frustrating, and it makes you wonder, why does so much software out there just feel kind of broke?
Well, a lot of the time, the answer is surprisingly simple. It was built without a real plan. I mean, think about it. You wouldn't build a house without a blueprint, would you? You might end up with 4 walls and a roof, but would you trust it? In the world of software, the test strategy is that blueprint. It is the master plan for making sure the final product is top-notch.
So, let's dive in and take a closer look at what this blueprint is all about and why it's so incredibly important for any software project.
So, what is a test strategy, really? It's what we call a high-level document. It's not about getting bogged down in tiny, nitpicky details. Instead, it sets the overall rules of the game. It defines what needs to be tested, what the goals are, and most importantly, how the team is going to prove that the product is ready for you, the end user.
Building this blueprint is actually a pretty straightforward 2-phase process. It all starts with answering one huge question. What are we actually testing here? Once we know the what, we can then move on to the second part, how are we going to test it? This simple what and how framework is the bedrock for everything else we're going to talk about.
Okay, on to phase 1, defining requirements. Think of this as the surveying part of building our house, right? Before you can even start drawing the blueprint, you've got to understand the lay of the land, and you have to know exactly what the person paying for the house actually wants.
So when we talk about defining what to test, we're really splitting it into 2 big buckets. On one side, you have functional requirements. These are the things the system absolutely positively must do. But just as important, on the other side are the non-functional requirements. These define how well the system needs to do all that stuff. Getting this distinction is totally key.
Functional requirements are the features you can actually see and touch. Can you log in successfully? Does the Add to Cart button actually add something to your cart? It covers all the basics, from simple calculations like adding or deleting info, all the way to really complex stuff like security rules for who gets to see what. These are the bread and butter functions of the software.
Now, non-functional requirements, they're all about the quality of the experience. How fast does the website load? That's performance. Does the app randomly freeze or crash? That's reliability. Is it actually easy and intuitive to figure out? That's usability. You don't build these things like features, but they are absolutely what separate a good product from a great one that people love to use.
Okay, so once we know what we're testing, it's time to shift gears into phase 2, choosing the right approach. This is where we stop surveying the land and start drawing the actual blueprint, making those big decisions about how we're going to guarantee that all those requirements are met. This phase really boils down to 3 key decisions. First, we have to pick the right types of tests for the specific job. Then, we figure out the level, or the stage of development, where each of those tests is going to happen. And finally, we nail down the exact tools we'll need to get it all done.
And here's where those levels and types really come together. You can see how we map certain tests, like security testing, to specific stages of development. Early on, developers run unit tests on tiny individual pieces of code. Much later, we'll run system tests on the whole shebang. A good strategy makes sure the right tests happen at the right time. I mean, you wouldn't check the plumbing after the drywall is up, right? It's the exact same logic.
And finally, you've got to have the right tools. The strategy document clearly spells out what software we're going to use for which task. So, for instance, we might use a tool like Jira to keep track of bugs, something like Selenium to automate those repetitive functional tests, and maybe OpenSTA to see how the system holds up under a lot of traffic. This makes sure the entire team is on the same page, using the same approved toolkit.
So let's pull all these threads together. When you take the what from phase 1 and you combine it with the how from phase 2, what you get is your complete, finished blueprint for building quality software.
So here's the bottom line. A really powerful test strategy is a simple but critical equation. It takes that whole list of requirements, both the functional and the non-functional ones, and it pairs them with a super clear, organized plan for how every single one is going to be checked. This is what separates hoping for quality from actually engineering it right from the start.
At the end of the day, a test strategy isn't really about finding bugs. It's about building confidence. Confidence for the team that their product is reliable, and confidence for you that it's secure and does what it says it will. So the next time you use a piece of software that just works perfectly, you can bet it was built on a solid blueprint. It makes you wonder, doesn't it? How many of the apps you use every day aren't? Thanks for joining this explainer.